Hello, my dear 12th standard students. A very warm welcome you all to the discussion, chapter Ray Optics and Optical Instruments. And in this video, I am mainly focusing on MCQ questions from this lesson. Alright, as you all know, in board perspective, this chapter have higher weightage lesson. So you can invest good and more time on these lessons. So you will get good benefit in Cbse board 12th standard examinations. Alright, so to run in any physics chapter successfully, you require to form what? The first of all, a formula sheet will help you to tackle all the numericals from the lessons. Alright, in that way, first of all, in this chapter, before starting this discussion, you can make what? A formula sheet. You guys can take what? An A4 sheet and let's togetherly make a formula sheet. All right. Yes. So here I written all the headings of the equations. So let us write the equations now. So first one we have to study mirror formula. You learned from class 10 standard onwards what is mirror formula, right? So what is mirror formula? 1 by F is equal to 1 by V plus 1 by U. That's what we called mirror formula. Fine. So you can make that one beautifully, you can arrange, okay? You can arrange that one beautifully with the different colors. Alright, that's what the mirror formula. No doubt in that. Then another fact you want to remember, in addition to the mirror formula, in mirror area, F is equal to half of the radius of the mirror. How focal length and radius are related? F is equal to R by 2. Keep that in your mind. And also in mirror, you record, remember, magnification of a mirror. How will you calculate magnification? M is equal to minus V by U, which is also equal to size of image to the size of object, Hi by Ho. Remember these many capsules in mirror for mirror related ideas. Now let's look refractive index. So what is refractive index? N is equal to C by V, right? Do you know what is C? It's a very important equation, okay? Chota equation, very small equation, but it is very, very important. Very, very important. Can give like sometimes 1 mark very easily. Okay, what is C? What is C? C is the speed of light in vacuum, right? What's the value? 3 into 10 raised to 8 meter per second. That awareness is also needed. That's fine. Then another formulated refractive index, that is N is equal to sin I divided by sin R. Angle of incidence is I, angle of refraction is R. Okay, that is another formula. Keep that one also in your mind. Let me keep in box. Yes. Another formula related to refractive index is, that is in terms of wavelength. Wavelength of light in vacuum divided by wavelength of light in medium. So what is lambda 0? Wavelength of light in vacuum to the wavelength of light in medium. This is also Cbse, MCQ questions coming area. Keep in your mind that equation also. Okay, refractive index. And most important another equation is N is equal to refractive index from critical angle. N is equal to 1 by sin C, where C is the critical angle. Keep in your mind that formula. And another result in refractive index to remember, let me write here, that is, if you are comparing two refractive index of two mediums, like N2 by N1, refractive index of second media with respect to first media, then you can, that is equal to V1 by V2. Refractive index of medium 2 with respect to medium 1 is equal to speed of light in medium 1 divided by speed of light in medium 2. I will show the demonstrating questions. So keep in your mind that relation also. Okay. Yes. That all formulas you just keep in your mind. N is equal to 1 by sin C. And come back to the prism formula. When we come to the prism case, prism, refractive index is equal to, prism refractive index can be written as N is equal to sin A plus D by 2 divided by sin A by 2. Refractive index of the prism. One of the important formula, refractive index of the prism. In prism, you remember angle of prism, where D is called what? Angle of minimum deviation. Angle of prism is related to sum of angle of refractions in prism, A equal to R1 plus R2. Remember that relation. And moreover, angle of deviation is also equal to, minimum deviation is also equal to 2i minus A. Keep these many facts related to the prism formula. All right. Now, refraction of light through the curved surface. So that's the formula. N2 by V minus N1 by U is equal to N2 minus N1 by R. That's a formula for refraction of light through a curved surface. Keep in your mind the fact that here this formula is valid when light is moving from rarer to denser. This formula valid when light is going from rarer to denser. When light is moving from rarer to denser. Okay. N1 means what? Refractive index of the surrounding medium. N2 means refractive index of the spherical surface. Keep in your mind that idea. And here, what if it is like when light goes from denser to rarer? When it is denser to rarer, suppose when it is denser to rarer, what do you want to change? N1 and N2 just exchange. Interchange the place of N1 and N2. The same equation in place of N2, if you write N1 and N1 place if you write N2, then that formula valid for what? When the light is going from denser to rarer medium on a refraction of light through the curved surface. Keep in your mind that one. And then lens maker's formula. What's the lens maker's formula? 1 by F is equal to N2 by N1 minus 1 into 1 by R1 minus 1 by R2. That's what we call the lens maker's formula. What is N2 stands for? Refractive index of the lens. N1 means refractive index of the surrounding. So if it is the surrounding is most of the case it is air, then here it will be what? Simply N only, refractive index of lens only, because N1 can be 1 that case. All right, that's what we call the lens formula. Then what is lens formula? 1 by F is equal to 1 by V minus 1 by U. This is called lens formula. And here, related to the lens, you want to remember magnification formula V by U, which is also equal to HI divided by HO. Where HI and HO are called what? Size of image and size of the object. All right. Now, the next one will be power of lens. What is power of lens? Reciprocal of focal length. What is power of lens? Reciprocal of focal length of the lens is called power of lens. And another thing will be, suppose you join many lenses together. We are arranging like many lenses together. Then what will be the power of combination? Like you are arranging the lenses together. That time, what will be the expression for total power? Very simple. P1 plus, you just take the sum of individual power of all lenses. Okay, what is P stands for? The total power, effective power. Okay, so that is the formula of power of lens. P1, P2, P3 are the individual power of lenses. That's fine. Okay, so this is what we call we can call this is P effective, total power of the combination or resultant power. If they ask like what will be the focal length, effective focal length, then take the reciprocal of after finding the total power, take the reciprocal. You will get what? Effective focal length. All right. So keep in your mind this all formulas. You can take a screenshot of this. All right. Yes. More formulas coming. Next part, optical instruments. Okay. Optical instruments. Symbol microscope. So I think you can, you will get you can able to solve the numericals. So symbol microscope and compound microscope, refracting telescope, etc. By learning the equation, you can easily, sometimes the question in Cbse, they're going to ask like easily numerical awareness checking questions. A student know the formula, simply go and substitute. You will get the answer. Okay, such questions they will gives in the paper. So let's do the symbol microscope formulas. Relaxed eye, minimum magnification case. Minimum magnification case, the symbol microscope formula is D by F. where D is the least distance of distinct division. Least distance of distinct division. For normal eye, it is 25 centimeter. Sometime, optical instrument used by some defect persons, eye defect persons, so D will be varies depending upon the person. So if nothing is mentioned in the question, by default you can take D as 25 centimeter. That's a normal least or near point of persons. Okay, that's fine. Then here, a strain division case, that's a maximum magnification asking time. You can use the formula 1 plus D by F, where F is the focal length. That point you should remember in simple microscope. And compound microscope coming time. Compound microscope, first of all, minimum magnification or relaxed eye. There are two types of settings, right? Relaxed eye and strained eye. Over here, the formula comes VO by UO into D by FE. D by FE. Okay, D by FE. Where VO and UO are called what? O stands for objective lens. E stands for what? Eyepiece. So, image distance of objective, object distance of objective. D as usual, 25 centimeter for normal eye. FE means what? Focal length of eyepiece. That's fine. And strained eye time, the formula comes like M is equal to VO by UO into 1 plus D by FE. 1 plus D by FE. That's the result. Okay, keep in your mind. So this is the accurate formula, and one approximated formula is also there, that is L by FO into 1 plus D by FE. Okay, yes, sometimes the length is given, then you can use this formula, L by FO into 1 plus D by FE. That is depending upon the situation of the question, select either of them. Fine, right? Now when we come to the refracting telescope, relaxed eye, so this is very important formulas, okay? Relaxed eye, FO by FE. And over here, most important relation is between focal length of objective and eyepiece and tube length are related like L is equal to FO plus FE. Tube length of refracting telescope. This relation is very important, okay? These relations are very important. And when we come to the strain division magnification, the formula comes FO by FE into 1 plus FE by D. That's a formula for magnifications, maximum magnifications in refracting telescope. Refracting telescope. You got this, right? So again, you can take a screenshot of this complete thing, complete formulas, and recall this all formulas. Okay. Now let's do a couple of questions related to this. Fine. So let's come to the first question. Can you pause the video and try to figure out yourself one round this one? Yes. The refractive index of, let me read the question here. The refractive index of converging lens is, what do you mean by converging lens? Convex lens is 1.4. What will be the focal, so refractive index of lens is given 1.4. What will be the focal length of this lens if it is placed in a medium of same refractive index? Oh, lens refractive index represented by N2, surrounding refractive index represented by what? N1. Refractive index surrounding is also what? 1.4. It is given same, right? Refractive index of the surrounding lens gonna place in the same medium, similar type medium. So refractive is also same. Then question is asking, what will be the focal length? What will be the focal length? Can you pause the video and think which formula we will use here? You got the idea? Which one we will use? All right. Definitely this is a lens question. Refractive index of lens is given. Surrounding is there. Focal length is asking. Lens maker's formula. We can use lens maker's formula. What's lens maker's formula? Can you say F1 by F is equal to N2 by N1 minus 1 into 1 by R1 minus 1 by R2. What's the N2 and N1 value? Same. Same. So 1 by F equal to N2 is 1.4, N1 is 1.4. So what you will get? What you will get? 1.4 by 1.4. 1. 1 minus 1, 0. So you will get 1 by F is equal to 0. 1 by something is 0 means that something will be, call it as infinity. Oh, very easy answer, right? Yes, easy question. So you got it is infinity. Option B is the right answer. Got the idea? Yes. Let's go to the next question. Yeah, let's look on this question, all of you. A spherical air bubble in water will act as a, is one of the very famous question. Keep in your mind. A spherical air bubble in water. Okay, fine. Yeah, let me draw an air bubble here. Yes. Let me draw an air bubble here. Yeah, see this one? There is an air bubble. Fine. I need here principal axis to draw. Yeah, fine. Let me draw a principal axis. Fine. And this will be the center of the sphere, air bubble. What is inside here? Air. Air. What is outside? What is outside? Outside medium is water, right? Air bubble in water. So what is outside? Outside is water. We want to, find here, this air bubble is act like what? It behaves like a convex lens, concave lens, plane glass, etc. So let's start drawing the ray diagram of this. Then you will get the idea. Come on, which color I can use? Let me use this. Okay. Yeah. So imagine I kept a bulb here. So say a light ray is coming from the bulb, which is striking over here. Let me mark this as an incident ray. Fine. Then what will happen to that light ray? I need a normal, right? How do you draw the normal to the curved surface? Very simple idea. If I need a normal here, connect the central point and the point of incidence. This is gonna call normal. That's an easy way to draw the normal. Okay, fine, agreed. Now see, what will happen to this incident ray? Is going from water to air. Water is a denser medium, air is a rarer medium. So denser to rarer, bend away from the normal. Bend away from the normal. This is not bending, this is close to the normal. This you call the normal, right? So bend away from the normal, look like this. Bend away from the normal. You got it? Bend away from the normal. Now again, at this point, light is going to change air to water, right? So definitely at this point also, refraction will take place. Let's study the refraction at that point. Okay. Again, I need the normal, right? What should I do to draw the normal? Connect that point and center, or center and that point. Fine. This is a normal here. I hope you got the idea how to draw the normal in everywhere, right? Okay, fine. Now see, light is going from air to, inside is air, it's air bubble, air to water, rarer to denser, bend towards the normal, right? So it will bend towards the normal this way. Normal is there. So refracted ray want to hug the normal. So it's going to be like this. You got it? Yeah. So that's the refracted ray. Fine. Now what is happening to this whole light ray? It's going to diverge. So air bubble makes this light ray to diverge. Therefore, this air bubble, we call it as concave lens. What we call? Concave lens. Got the idea? Diverging lens is concave lens. Now you can think about like different mediums, the same story with a different medium. So that's a good question. Keep in your mind, okay? Let's do the next then. Listen to this question. Can you read this question? A biconvex lens. Two sides are convex. That's why it's called a biconvex lens. Of glass having refractive index is 1.47. Okay, agreed, no issue. It acts as a lens wanna make into plane sheet. What is plane sheet? What is plane sheet? Plane sheet means if a light is striking on a plane sheet, the light wanna go undeviated. Then we will call that act like a plane sheet. So what am I plane sheet? There is no refraction. When light strikes, it will be refracted in the same line. Okay. It won't bend, which means refracted ray won't bend. That's what we call the plane sheet. But we have a convex lens, right? What we have? We have a convex lens. So when this convex lens acts as a plane sheet, which means Usually we know when a parallel light ray strikes, it try to converge, right? Why it is try to converge? Because inside the lens, outside the lens are different refractive index. What if the inside medium, outside medium having same refractive index, same material, if inside is glass, outside is also glass. Think about that situation. Will there be any bending? No. There is no refractive index change. If I imagine like outside medium, inside the lens are made up of same material, then there is no refraction. Light gonna be straight, undeviated. So when a lens behaves as a plane sheet, when the refractive index of the lens and surroundings are same, turns to be same. Okay, not only this convex lens. Well, if you take a concave lens also, inside medium and outside medium are same, then it won't diverge the light ray as usual. It will allow the light to continue in the same line. Now this is not called as lens. This is called as plane sheet. So it's a very important concept. Keep in your mind. So when a lens will behave like a plane sheet, when the refractive index of the surrounding medium and the outside medium, inside medium are turns to be equal to the glass. Fine, you got the idea? You can approach this concept in one more way. Look at this. The lens maker's formula also will help you. 1 by f is equal to n2 by n1 minus 1 into, I'm not focusing on the other part. Oh, let me write anyway, 1 by r1 minus 1 by r2. If the both medium refractive index turn to be equal, if n1 and n2 are comes equal, what you will get? You will get 1 by f is equal to 0, as like we solved before, which means focal length is infinity. Focal length is infinity means it's a plane sheet. Light ray won't converge in the near place, it converge in infinity. Okay, so when the medium refractive index are equal, focal length become infinity. It means it acts as a plane glass. You got the idea, right? Yes, keep in your mind. That's a good question. Let's move to the next thought. Can you read this one? An object approaches a convergent lens, which is called convex lens, from left to the lens, from left of the lens, okay? Yeah. So here there is a convex lens, it's a principal axis. Let me mark some points called 2f1, and this is what you called f1, this is what we called f2, this is what we called 2f2. Now, what you are thinking? To make this problem beautifully, let me consider a man is walking. An object is approaching is a boring. So let me make a challenge. A man is approaching to the convergent lens, convex lens. With what speed? 5 meters per second. The man is walking with what speed? 5 meters per second. Constantly approaching to the lens. Okay, like this. Then what will happen to the image? Will be image also goes like in the same speed as the object? That's actually the question asked. Object is coming in the same way. If we imagine this I am, okay, I'm walking towards the lens. What will be my image? My image also walk in the same speed or it is different speed? That's actually the question asking here. Fine. Look over here. When objects coming closer and closer, it's a 10 standard idea basically. When objects comes at 2f1, image will be at 2f2. You know that, right? When I walk and reaches at 2f1, image will be at 2f2. Then if I little more I moved, if I covered little distance, when I am here, look at this, when I reach it here, then my image will be at 2f2. Okay, if I shift my place little to here, between 2f1 and f1, where my image is here. Second case. Let me use different color in different situations so you can easily recognize. Then when I reach at f1 at focus, where do you see my image? My image will be goes to infinity. So what I said, when I am at 2f1, leave it about this case. Okay. When I am at 2f1, my image is at 2f2. When I am at in between f1 and 2f1, I will be away from 2f2. Okay. Then when I reaches f1, I reaches infinity. So see, here I am traveling equal distance in equal seconds. What about the image covering distance? They are unequal. One second I am here, next second I am here, next second I am there. So too far, right? How can I travel like this? Unequal distance? Definitely my acceleration is not uniform. Okay, so which option will be true then? It is non-uniform acceleration, because initially I am running slowly, later I run fastly. So it's called a non-uniform acceleration. So moves away from the lens. How I am going? Moves away from the lens. Non-uniform acceleration. Option B is the answer. You got the idea, right? Yes. Let's move to the next question. The radius of curvature of, you can also pause the video and try to figure out yourself. Okay, fine. Radius of curvature of a curved surface of plano-convex lens is 20 centimeter. Plano-convex lens. Okay, fine. So let's draw the plano-convex lens. One side is plane, other side is convex, bulges outside. It's called the plano-convex lens. One side is plane, other side is convex. The radius of the convex side is given 20 centimeter. As you all know, what's the radius of the plane side? Infinity. Radius of the plane side is, what's the radius of the plane surface? Infinity. Keep in your mind that part. Refractive index of the lens is, that is what we call N2, is 1.5. It will act as a concave lens irrespective of the side in which the object lies. Okay, so you can read the options. How do I know it's act like a convex lens or concave lens? I will tell you the idea. Listen carefully. You know lens maker's formula? Tell me. 1 by f is equal to n2 by n1 minus 1 into 1 by r1 minus 1 by r2. Professor, why you written here n only? Oh, brothers and sisters, if they are not mentioning about the surrounding medium which lens is kept, then by default you can assume to be taken as air. Okay? Or otherwise they will say what? The lens is kept in water. Something they will give the hint. But here no hint is given. So by default you can assume it is in air. So N1 will be here 1. N2 is taken as N. That's all. Okay, fine. Now 1 by f is equal to, according to this diagram, this is what you called R1, this is what you called R2. So 1 by f is equal to, what I will get? N is 1.5. So 1.5 minus 1, 1.5 minus 1 into 1 by R1. How much is R1? 1 by 20. How much is R2? Infinity. We don't want to solve this, okay? Because it's not a numerical, right? So why we need to waste the time? As you all know, 1 by infinity becomes 0. What you will get the f here? We don't want the value, but I'm sure you will say f is positive, right? If you solve this one, what's the value you will get? F is positive. Fine. Keep in your mind that idea. Then when we come to the second case, what if this one is one way we arrange the plano-convex lens? What if you keep the plano-convex in opposite manner? Okay, oppositely you kept. That means here in this case, object is kept where? On the side of convex side. Here I am going to keep the object is on where? Object is on the plane side. Will be again, will get focal length is positive or not, we can check it. Yeah. So what's the formula? 1 by f is equal to, refractive index of lens is not changing. But what is R1 here? What is R1 here? Here this is what we called R1. That's the plane side, infinity. What's R2 here? What is the radius of the convex side? 20 centimeter. Will it be 20? No, it is minus 20 centimeter. Why? It's minus 20. Sign convention. That is, if the curve is facing towards left side, okay, any measurement which is taken against, what is the radius of this one? How will you measure the radius? Towards left. How will you measure once again, how will you measure the radius? Towards the left, negative. So radius is negative. Professor, but here you took radius positive. Can you check it? Yeah, this curve, facing towards the right side. So radius gonna be positive. So in short, if the radius is like, the curve is facing towards the left side, then substitute radius as negative. If the curve is facing to the right side, substitute the radius as positive. That's the idea, okay? So therefore here, R1 is no doubt infinity minus R2. R2 is negative 20. Negative 20. Now tell me, negative, positive. 1 by infinity, 0. What will get f you solve from here? We don't want to solve. You'll get f is positive. So wherever you place the object in a plano-convex lens, if you place the object on the plane side or convex side, no matter, every time we are getting focal length is positive. So what we can conclude, focal length is positive means it is a convex lens. Okay, what's that idea? Keep in your mind, if you are getting focal length is positive, what we call that lens? That lens, we call it as convex lens. Therefore, irrespective of the position of the object, we are getting focal length is positive. Therefore, it is convex lens. You got the idea? So, which option will be the correct? Act as a convex lens irrespective of the side of the object. Where you kept the object is not a matter. Focal length is positive in both cases. Focal length positive means convex lens. So, you indirectly learn one more thing. If it's a focal length negative, which means it is a concave lens. Keep in your mind that fact too. Got it, right? Let's go and discuss next question. Oh, this question, very, very evergreen question in chapter ray optics. Every time, so one of the very famous questions. I forgot the page number of NCERT. So one of the NCERT textbook pattern example question, I think. Yeah, one exercise question also with the numerical is present. Yeah, hopefully you all tried this one. If you already learned this one, can you pause the video again and try to identify which option will be the correct? See, whatever the question we are discussing, it's an MCQ, but MCQ in physics, it can be like 2 mark question standard. 2 mark question standard. So MCQ questions and 2 mark questions are, practice will be same only. That means this practice will be useful. Okay. So look at this question. A point source of light is placed at the bottom of the tank filled with water. Refractive index is mu at a depth d. The area of surface which the water through which light from the source can emerge out is. Hopefully you read the question well. Let me draw the diagram. Let me draw the diagram here. There is a tank is mentioned in the question. Let me draw a tank. Oh, how beautifully I am drawing the tank. Oh, good tank. Yes. So let me mark here water. Which color I will use for water? White, sir. Yes. Oh, it comes as yellow. That's great. So it's water. Just keep in your mind. Then here it is a point source. A light we kept at the bottom. What is one? It's a bulb you can imagine. A light source. A bulb you can imagine. Bulb you can imagine. Fine. Then what will happen here? Let's look. When a parallel light ray, let me change the color. It's a light ray. Can I use this color? Okay, fine. When a parallel light ray strikes, not parallel, this is called perpendicular, right? I'm sorry. Perpendicular light ray from the bulb. Bulb is sending too many light rays. But look at one of the light ray. It is going from water to air. How it is going? Perpendicular to surface. So it goes undeviated way. You know that, right? It goes undeviated manner. So that light will goes up. Fine. I'm not drawing completely that part. But light, as you know, light goes up, right? What about the another light ray? Which is striking here. Yeah, it refracted away from the normal, right? Away from the normal because light is going from water to air. But look at this kind of light rays. This kind of light rays. What happened to that light ray? I'm coming to the end of the answer very quickly. This light ray grazes the surface. You know the concept because this angle can be equal to critical angle. This angle can be equal to critical angle C. What happened to the when the angle is equal to critical angle? it grazes the surface instead of refracting. Similarly, by symmetry, to this side also what will happen? Oh. Due to the symmetry, what happened to this light ray also? It also grazes the surface. What will happen to the light ray beyond this? Beyond this, I mean this light ray. What happened to this light ray? Will it be graze the surface or will it be refract? No, it will be reflected back. What we call that? Total internal reflection. Which means these rays are not coming to out, right? So this area where this corresponding to this side, this side will be act as a dark. So a person who looking outside sees the light only through the circular face. What about the rest of the light ray? Reflected back. So that corresponding side will be dark. Here it will be dark. So observer will see the light ray through the cone. Okay, it's coming from circle. The question is asking, find out the area of the circular face. How do we solve that? Yeah, to solve the area, we record radius. To find. And what they call the depth is d, right? The total depth is d. So this height is d. Since this angle is c, therefore this angle is also c, right? C called the critical angle. What do you call that angle in mathematics? Alternate interior angle. That's fine. Now look at this triangle, okay? Triangle, this triangle. Let me mark that triangle, some name. B already called, so I can call this is A, and C already used here, ABD then. Triangle ABD. Look at the triangle ABD, all of you. Yeah. What is tan C? Tan C. Oh, tan C. Opposite side. What's the opposite side of this C? R. Opposite side divided by adjacent side. R by D. So what is R then? R is equal to D tan C. R is equal to D tan C. What I want to find? I want to find the ray area, right? Area. I got the radius D tan C. But let me modify this. R is equal to D into tan can be written as what? Little bit mathematics come here. Sin C by cos C. That's fine. One more change let me make here. R is equal to D into sin C divided by cos C can be written as root of 1 minus sin square C. Simple mathematics, just learn that. Cos of an angle can be written as what? Root of 1 minus sin square of the same angle. Okay, why I am writing that way? Listen. Because I know one more relation. N is equal to 1 by sin C. But here they are not called N as refractive indexes. N instead they called mu. So let me turn into their letter. Mu is equal to 1 by sin C. So what is sin C then? Sin C will be 1 by mu. I have this relation. Go and put there. You will get the radius. Come on. What will you get? R is equal to D into sin C 1 by mu divided by root of 1 minus 1 by mu square. Okay. How do we solve that? Yeah, let me solve here. R is equal to D into 1 by mu divided by, you can take cross multiplication. What will you get? Mu square into 1, mu square minus 1, root of mu square minus 1 upon mu square. Fine. What is the root of, what will be the answer of this part? I mean root of 1 by mu square can be written as mu square minus 1 by mu, right? I can take mu square out of the root. I will get like this. Then can cancel these. What I will get? The radius. Radius is equal to D upon root of mu square minus 1. That's the radius. How I find the area then? Once I got the radius, finding area is very easy. How will you find area? Let me find area here. Area is equal to area of a circle. If the radius is known, area of a circle will be what? pi r square. Area of a circle is pi r square. What's the radius I got? I got the radius is this one. So square this. When I square that, I will get d square upon pi. When I square the root got cancelled. Mu square minus 1. So pi d square by mu square minus 1. What's the option? Option is near to me. Option B is the answer. Okay, it's a very important question. Keep in your mind. Actually, it's a 3-mark weightage question, but they can be asked like an MCQ also. So you can fix it in your MCQ in your mind. Okay, so very repeated MCQ questions. You might experience this question in your school examinations also, right? Regularly. Okay, fine. Keep in your mind this. Okay. So one similar type question will be there over here with the only difference is what? The numbers is given as numbers, numericals. You can read this question, and this question I am giving as an homework question to you. Try to figure out your answers. Then please let me know in the comment box your answer. Okay, then I will check it whether it is wrong. I will make a small video or I will do the corrections by chatting. Okay, fine. So same question itself, you can solve this. Okay, you should try to solve. Moving on to the question number 8. What's the question number 8 is? For a glass prism, the angle of minimum deviation will be smallest for which light? This is a theoretical question. Which color of light have minimum angle of deviation? Minimum angle of deviation and refractive index of the prism. How they are related? Any idea? Refractive index of the prism, n is equal to sine of a plus d by 2 divided by sine a by 2. Okay, you should think like this. Okay, what they were asking the question? Minimum deviation and color of light. Color is definitely related to wavelength. Wavelength can be connected to refractive index. So, is there any equation is there between minimum angle of deviation and refractive index connection equation? Yes, obviously this equation is the connecting one, right? Okay, fine. Now, yeah, as you're looking here, you can see, we don't want the values, but you can see N and D are face to face, right? So we can say angle of deviation is directly proportional to refractive index. Value of D increases, value of this function will increase, will get more N value. When the D reduces, this value reduces, N decreases. So when D decrease, N decrease. When D increase, N increase. So therefore, they are directly proportional. They are directly proportional. We can write like this. Okay, agreed. Then how we can connect with refractive index and color? Refractive index, have a relation with the wavelength inversely proportional. Wavelength and refractive index are inversely proportional. Okay, we are close to the answer. Then we need to what? We need to find what? The angle of minimum deviation will be smallest. So when I get small, the value of D is less. Value of D is less when the value of refractive index is less. When the value of refractive index is less, when N will be less, when lambda is more. More is the wavelength. Come on, we can play. More is the wavelength, lesser is the refractive index. Lesser is the refractive index, lesser is the angle of minimum deviation. Okay. So wavelength is more for which color? Red have more wavelength. You can remember like red first letter Rafi. So Rafis are have greater wavelength. Oh yes. So here you can see. I will say that's fun. Leave it. So here the wavelength order. Wavelength is more for which color? In short, it is red. So answer is red is the answer. Answer is red color is having minimum angle of deviation. But see guys, if you know the order of the wavelength, you can remember like this. Some creative diagram. This is what the order of wavelength. Okay, this is what the order of wavelength. As you go from violet to red, wavelength will increases. Wavelength will increases. Keep in your mind this question. Okay, yeah, fine. Let's go to the next question. Can you try to solve this? Pause the video and try to solve. Yes. All right. Then please look here. A window is provided in the middle of wall. Okay, no issue. There is a wall here. Let me draw a small window. This is what the window. Okay, so wall 1. Okay, wall 1. Then where is the wall 2? Image is obtained on opposite wall, and opposite of this another wall is there. And we gonna make the image of this window there. Okay, image of this window. So let me draw the image of this window. And they were said that image also same size. What's this one? Window. So image of the window is also same size. That's a hint of this question. One wall, there is a window is present. With the help of some lens, we are actually forming image on opposite wall, having same size. Then what will be the focal length of the lens we used? Definitely to get this one, we used what? A convex lens. We used a convex lens to form the same size image. The question is asking, then what will be the focal length of this lens? Okay, we can find the focal length of the lens. So principal axis. This is what we'll call it as, this is our object. That's window. What is one? Image. What about their size? Are they same or different? Yes, they are same size. Image and object are same size. Window having same size. When do we get image and object having same size in convex lens? If you forgot, keep in your mind, when object is kept at twice the focal length, that point you should remember. When object is at 2f1, then image will be at 2f2 having same size. That's a class 10 standard ray diagrams. If you have a time, go and check it out, the ray diagrams of convex lens when object is at 2f. What's the property? When object is at 2f, image will be also at 2f having same size. What they were given here, the total distance is given as d. Question is asking what's the focal length. If the total distance is d by, then what will be this distance? D by 2, right? D by 2. Then only this could achieve, right? The lens has to be exactly middle, because object and image size are same, means object distance and image distance also same. Object distance and image distance also same in this case. Object distance and image distance also same. So to get that, you had to keep the lens exactly at the middle. Otherwise, you won't get. What if you can think like this? If you are not getting that point, you can think like this. What if whereby I kept the convex lens? What if I kept the convex lens somewhere here? Is it object distance and image distance are same? They are not same. If they are not same, I won't get like the same size image. So this condition could not achieve, right? So when this condition could achieve, when the lens should be exactly middle of it, object distance and image distance must be same. And one more point, this image distance also equal to what? Twice the focal length. So therefore, twice the focal length is d by 2. So focal length is d by 4. The field is a convex lens, so focal length will be positive, as I said before, right? So plus d by 4 is the answer. Fine, right? Yeah. Let's go to the next question. Just read this question carefully. When a ray of light enters from one medium to another, velocity is doubled. Okay, velocity is doubled. Then what is the critical angle? So based on the first two lines, can we figure out the mediums? Yeah, there is a boundary, and above like one medium is there, medium 1, and it's a medium 2. And the speed of the light is doubled, right? Which medium speed of the light will be increases? Which medium? What we call the medium, name of the medium in which speed of the light is higher? Rarer medium. What we call? Rarer medium. Light is fastest medium is called what? Rarer. Light is slowest medium is called what? Denser. So the first medium is denser, second medium is rarer, because when light is moving from medium 1 to medium 2, the speed is doubled, speed is increasing, light going fast, so the second medium is rarer. Got the idea? Yes. So actual diagram is not needed, but making for the concept, let me draw here, okay? It bent away from the normal, this case. If I call the speed of this medium is v, what's the speed of this medium then? 2v. What should I want to find? I want to find the critical angle. How refractive index and critical angle are related? refractive index and critical angle are related, the relation n is equal to 1 by sine c. N is equal to 1 by sine c. When both mediums are denser, and in terms of denser and rare, I can write like this: refractive index of denser medium with respect to rarer medium. Okay, if it is one medium is air, then simply n equal to 1 by sine c. If two mediums are not air, then you should write like this: nd by nr. You want to remember one more relation: nd by nr can be written as in terms of velocity. Yeah, let me write here. You already know this: n to 1, refractive index of second media with respect to first media. How will you write? v1 by v2. That is, second media with respect to first media will be velocity of light in rarer medium to the velocity of light in denser medium. Keep in your mind this: refractive index of denser media with respect to this, read as refractive index of denser media with respect to rarer medium is equal to speed of light in rarer medium divided by speed of light in denser medium. Okay, fine. So therefore, let me use here speed of light in rarer medium to the speed of light in denser medium is equal to 1 by sine c. What is the rarer medium speed here? 2v. So rarer medium speed is 2v. What is the denser medium speed here? v, which is equal to 1 by sine c. v mar gaya. What will get then? We'll get 2 is equal to 1 by sine c, which means sine c is equal to 1 by 2, c is equal to 30 degree, right? Sine of an angle is 1 by 2 means angle is 30 degree. So option is 30 degree is the answer. Got the idea, right? So relaxly, you can again watch this one, okay? Fine, if you have a doubt. Still you have a doubt exists, because physics is like, your thought is going on in multiple directions. So you might come across the doubt. In case doubt coming time, please let me know in the comment box. Okay? Yes. Look at this question, all of you. A biconvex lens of power P by, sorry, I'm wrong. A biconcave lens. Biconcave lens. Both sides are concave. Both sides are concave. Biconcave lens. What's the power of this lens? Power of this lens is P. We are splitting this lens. We are, splitting this lens. We are splitting this lens. Oh, when splitting time, how the color change, Rafi sir? Color won't change. Oh, again, wrong. This color is correct? Yeah, it's correct. Okay, when you split this one, it will be like this. Split into two equal part, right? I think they splitted for giving their friends. Okay. Diagram is not exactly, but you can assume. Split like this, okay? Split this way. Then question is asking, what will be the power of each part? How they are splitting? Are they split unequally or identical? Identical, same. Both pieces are what? Same piece only, same. So therefore, I don't know the power of this. I'm going to call this is P dash. If the power of this one is P dash, then what can I call the power of that lens? P dash, because both of them are identical. Okay. We want to find what is the value of P dash. We want to find what's the value of power of each piece. What we'll do? How can we solve this? You can solve all physics questions multiple way. This also have, multiple way of solution will be there. But the best way comes in my mind is like this. They splitted, right? Can you think reverse? If you could join this, we'll get the actual lens, right? Come on. If you could join these two pieces, we'll get this actual, right? Actual one. Are you getting the idea? So, if I connect these two lenses together, then the total is this. Okay. I can use power of combination of lens formula then. When I combine two individual lenses, I am getting big lens. So I can use power of combination of lens formula. Okay, fine. What's the power of combination? What is the power of combination of Lenz's formula. Power of effective power or power of the combination or total power is equal to P1 plus P2. Okay. If I come, these are my individual pieces. So power of them, it is P dash. Other one is also P dash. What I want to get the total? Total as P. Oh, the problem is solved. So P dash plus P dash, 2P dash. So 2P dash is equal to P. That comes P dash is equal to P by 2. The answer is P by 2. Great, right? The individual piece power will be P by 2. Good. Yeah. Let's go and look another question. It's just an informative question. Keep in your mind this. When a light is passing through one medium to another medium, what is not change? We can learn that one easily because all other will be changes except two things. I will tell you that. When light passing from one medium to another medium, keep in your mind, you're asking like which of the following may change. They can also ask like which of the following may not change. Keep in your mind, read the question correctly. Okay. Definitely velocity will change. When light goes from air to water, speed of light, slow down. Air is, speed is higher. So light goes to the water, speed is less. Okay, fine. So no doubt, right? Wherever velocity will be there, velocity will change. So that option, velocity will change. Here velocity is present, here velocity is present. Okay, but you can think like this. I will teach you which one not change. Frequency and color of light won't change. Frequency and color of light won't change. So remember that point. You can keep it in a box, this point. During refraction. During refraction. During refraction. During refraction, frequency and color of light remains same. The values, unchanged. So keep this in your mind, okay? Because that is a property of the source of light. That's a property of the source of light, which means, example here air, here it is water. If I turn on the light from a torch, just assume I use a torch, or you can imagine like my iPhone 16, okay, my iPhone 16 torch, you can imagine. Yeah, so light ray is coming from my iPhone 16 to the air, then how it go? It bends towards the normal. So where from this light is coming to the water? From my phone. Where from this light to the air coming? From my phone. Are the source are different here? No, source is not different. The source of light is fixed. Where from this light is coming? Where from this light is coming? From the same iPhone 16. Source of light is fixed. How long the source of light is fixed? Then frequency won't change. Color also won't change. Got the idea? Yes, because these are the light ray from same parent. Therefore, frequency and color of light won't changes. Okay. So, therefore, this is the wrong option, right? They're asking like will change. So, frequency will change is the wrong option. Frequency will change is the wrong option. Velocity and wavelength. Velocity and color won't change, right? Color won't change. So, this is also wrong. Option D is the correct one. Velocity can change, wavelength can change. Velocity can change, wavelength can change, but color won't change. So this is not the correct option. Option D is the right choice. Keep in mind, it's a very important golden points, okay? Keep it in your box. Let's look at this question. The wavelength of the sodium light is, in air is given, wavelength is given. The velocity of light in air is also given. The refractive index of the glass is given. What will be the wavelength of light in glass, right? Okay. Refractive index and wavelength, how they're related? I told at the beginning the formula. Refractive index is equal to wavelength of light in vacuum or air. Wavelength of light in vacuum to the wavelength of light in medium. Example, refractive index of the glass is equal to wavelength of light in vacuum to the wavelength of light in glass. Like that. But the question is asking here wavelength of light, right? Lambda. Just swap the place. What you will get? Lambda 0 by n. What's the lambda 0? Wavelength of light in vacuum. It is given. Wavelength of the light in air or vacuum. Nearly same. So 5890. Divided by refractive index of the asked medium here. The asked medium here, glass. So refractive index of glass. Wavelength of light in air or vacuum divided by refractive index, then you will get what? Wavelength of light in that respective medium. If you do this calculation, what will be the answer? Yeah, the number is the denominator. We don't want to find the value, right? We don't want to find the value. If you have time, you can find the value, or otherwise itself we can say the answer for it. It definitely less than 5890, right? Because you are dividing with 1.6. So less than 5890, only one option is correct. Okay, so we can eliminate the rest option. This will be more than this. We will never get. When we get a value is more than the numerator when you are multiplying, not dividing. Whenever you are dividing with a number greater than 1, obviously the answer will be less. So option B is the answer. If you're feeling that's a confusion, you can find the actual. You will come across that answer. Okay, fine. You got it right? Yes. Look at this assertion reason type questions. Can you read this one? Easy question, I think. Can you pause the video? Try to figure out which option is the correct one. All right. Propagation of light. What's assertion saying? Propagation of light. Assertion saying propagation of light passing through the optical fiber due to total internal reflection taking place in the core and cladding surface. Yeah. Optical fiber cable. Optical fiber cable is on the basis of total internal reflection. Assertion is true, no doubt. What about the reason? What about the reason? Refractive index of the material of the cladding of the optical fiber is greater. Oh, wrong. In optical fiber cable, core has more refractive index. Core have more. What do we call core? This is inner side is core. Outside is what you call the cladding. So to occur TIR, inside must be higher refractive index. So core should be higher refractive index. But here it is given wrong. Cladding is high refractive index. So reason is false. We won't agree. So assertion is true, reason is false. Option C is the right answer. Assertion is true, reason is false. Got the idea? Yes. Now let's solve the next type. A point object in air is placed symmetrically at a distance 60 centimeter in front of a concave spherical surface, not lens. Concave spherical surface. Okay, let's try to figure out that. There is a concave spherical surface. It will be like this. Okay, it's like till up to infinity. Other end is till up to infinity. So it's a concave spherical surface. Fine. An object is placed in air. So here it is air. Let me draw the principal axis. So object is here. Okay, let's consider object is here. At a distance 60 centimeter, right? So this gap is given 60 centimeter from the spherical surface. This is 60 centimeter. What is that actually? Object distance, right? Object distance always negative. So negative 60 centimeter. No doubt. Then refractive index of the concave spherical surface. Refractive index of the spherical surface, we call it as N2. N2 here it is 1.5. Surrounding what is present? Air. So N1 is 1. N1 is 1. If the radius of curvature, radius of this one is 20 centimeter. Negative or positive? Is it negative or positive? This surface is facing towards left side. If a curve is facing towards left side, remember radius is negative. If a curve is facing to the right side, then it is positive. Keep in your mind, okay? We already used it before also. So here the curve is concave, right? Facing to the left side. So radius is negative. What's the value of radius? Negative 20 centimeter. What formula comes in your mind related to this? All refraction of light through a spherical surface. Obviously, curved surface formula. Curved surface formula, there are two types are there. One is used for rarer to denser, other one is denser to rarer. Which case is this one? One case is object in rarer medium. That case. Other case is what? Object in denser medium. So here object is in air. Air is a rarer medium. So light going from rarer to denser. So I will use the normal formula. What is that? N2 by V minus N1 by U is equal to N2 minus N1 upon R. I am repeating, students, this is not only an MCQ question. It can be asked like what? 2-mark questions also. Keep in your mind, okay? Yeah. So now it's a substitution. Now just substitution. Substitute all the value. N2 is 1.5. We need to find what? Oh, I forgot to ask that. Find the position of image. Position of image means value of V minus, what is N1? 1. U is how much? Minus 60. N2 minus. N2 is 1.5. N1 is 1 divided by radius is negative 20. Very careful about the ray optics numericals, okay? Because it's involved in the science properly. You guys can solve this, right? Yeah, 1.5 by V. This minus become plus. 1 by 60 is equal to 1.5 minus 1, 0.5. So 0.5 upon negative 20. Okay. So our aim is to find what is V, right? So transpose the 1 by 60 to there. So it's become, I think we can simplify here. 0.5 can be written as what? 1 by 2. 2 comes down, meet with the 20, it becomes 40. So we'll get minus 1 by 40. See, 0.5 can be written as what? 0.5 can be written as 1 by 2. Then that 2 comes down and meet 20, become minus 40. Then plus 1 by 60 goes to there, become minus 60. Play over here, you will get V value. I think if you solve this, you will get the V value around minus 36. Check it out, okay? Check it out that you will get the answer minus 36. Try to figure out. You got the idea, right? Yeah, refraction of light through a curved surface, one illustrating example. Let's go to the next question. Optical instrument area. Optical instrument numerical. Just read this question well, one round all of you. Simple numerical only. Especially the pattern of numerical from optical instruments, like a unique pattern. We can take a look on this question, all of you. What will be the magnifying power and length? First one asking for MCQ question, order is very important, okay? First they were asking what? Magnifying power and length. Magnifying power and length. What they were given? Objective focal length. Let me write that. Objective focal length. Objective focal length. How much is objective focal length? 3 meter. Very careful. 3 meter. Eyepiece focal length is 1.25 centimeter. What's the formula for magnifying power? Magnifying power is F4 by Fe. Telescope, right? So telescope. We can do the normal adjustment. By default, you can assume like normal adjustment. If you are not getting the answer with the normal adjustment, then you can check it for strain division also. But I think you will get the answer, no? Answer is like normal. Why I have a doubt? Because, here they were not mentioned like which adjustment is this one. So these cases you should try for, if MCQ question, you should try for normal adjustment and strain divisions. Then which option is getting correct, you can verify. Okay, don't feel like confusion. You have to do this one. I think we will get the answer directly. F4 is, but we should be very careful. F4 in meter, Fe in centimeter. We can't divide like two numbers having different unit. Make in either of them in both of them in same unit. So let me convert 3 into centimeter. So or you can convert centimeter to meter, whichever is comfort. You can follow that, no issue. So I think this 3 become 300. 1.300 centimeter. No? Look at this. 3 meter can be written as what? 300 centimeter. While you are finding the magnifying power, keep in your mind, both of the focal length should be in same unit. Maintain as same unit. If you divide this one, we will get the magnifying power. How much you will get? If you solve this, less than 300, right? Less than 300. So answer is here, magnifying power. Can you check it out? It's like 240. I think you will get 240 magnifying power. Then also asking what? So next part we don't want to solve, right? Next part, oh maybe next part we record solve. Yeah. What's the next part? Length of the telescope. What's the length of the telescope? Length of the telescope is f4 plus fe. What is f4? While you are adding time also, answers are in centimeter. So check it out this. You will get 301.25 centimeter. So magnifying power is 240. So option A is the correct one. Option A is the correct one. Easy question, right? Keep in mind, this is the type of questions usually comes in optical instrument. Take a look on next question. An astronomical telescope. Oh, read it carefully. An astronomical telescope of 10-fold angular magnification. So that's another way of communicating the magnification. 10-fold means 10 times. So its symbol magnification is 10. What do you mean by magnification? Image is how many times enlarged. Yes, it is given that 10-fold, 10 times. So magnification is 10, like that, okay? And length is also given. What's the length formula? Length value given here, 44 centimeter. What they were asking the question? Focal length of objective. They were asking focal length of objective. Tell me, how do we connect this one? Easy, right? Magnification is, Professor, f4 by fe. That is equal to 10. We have one equation. And length of the telescope can be written as f4 plus fe. That's equal to 44. You have two equations. You can find out f4 and fe. Easy, right? Can you pause the video and try to figure out yourself this? Okay, fine. Let me do. f4 equal to 10 times fe. From here, right? f4 is equal to 10 times fe. Substitute this f4 value here. What I will get? f4 can be written as 10 times fe plus fe is equal to 44. So 11 fe is 44. So therefore fe is 4. 44 by 11 become 4. So fe is 4 centimeter. But the question is not asking for eyepiece focal length. Asking for objective focal length. Okay, what is f4 and fe relation? 10 times fe, right? f4 is 10 times fe. So 10 times 4, that comes 40 centimeter. So answer is 40 centimeter. I got it. Yeah, 40 centimeter. You got the idea? This is the way you can approach this type of problems. See guys, here they can ask like both, okay? It's an MCQ question, that's why they asked only one, but it can be converted into 2 mark question also. Keep in your mind this. Fine. Let's go to the next question. Can you try to solve this? Next question. The magnifying power of a telescope is 9. Okay, welcome. Magnifying power is 9. When it is adjusted for parallel rays, the distance between objective and eyepiece is found to be, distance between objective lens and eyepiece lens in telescope is called it as tube length. So they are indirectly given tube length is 20 centimeter. Tube length is distance between objective and eyepiece called what? Tube length, 20 centimeter. What's the focal length of the lens? Means you want to find f4, you want to find fe. Same as like we done before. Can you try this? Pause the video and try to solve yourself. Let me help you quickly. Magnification is given. So f4 by fe is 9. So from here f4 can be written as 9 times fe. Then tube length relation. What's the tube length? 20. So therefore f4 plus fe is 20. f4 can be written as 9 times fe plus fe is equal to 20. 10 fe is equal to 20. F is equal to 2 centimeter. Yeah. Focal length is 2 centimeter. Eyepiece focal length is 2 centimeter. Go and substitute eyepiece focal length here. So we will get f4 is equal to 9 times fe. 9 times fe, right? So 9 times 2. 18 centimeter. So what's the first? Answer is 2 centimeter, 80 centimeter. Oh, answer is there. I'm lucky. Option A is the answer. 18 and 2. Got the idea? Yes. Let's have a look on the next question. Astronomical telescope, objective and eyepiece. Astronomical telescope consists of objective and eyepiece. No doubt it is there. The focal length of objective is. That's very simple question. What's the magnifying power of telescope? F4 by Fe. What's our intention? To make a less magnification telescope or more magnification telescope? What's our intention? Our intention always to see like enlarged view of the object, right? To get an enlarged view, we need more magnification. To get more magnification, F4 should be more, Fe should be less. So we'll make always what? F4 is greater than Fe. So objective, focal length of objective is greater than eyepiece focal length, greater than that of eyepiece. Option B is the right answer. Got it right? Let's go to the last question from the last year. Oh, that's interesting, right? Yes. So read this assertion recent question. The magnifying power of a compound microscope is negative. Yes, it is negative. Assertion. Magnifying power of a compound microscope is negative. Yes, it is negative. Why it is negative? Look at the reason. Reason says the final image formed is, oh, that reason is wrong. Final image is formed erect. No. If you check the ray diagrams of, a microscope, it is not erect, right? The final image is inverted. Let me draw quickly that diagram here. Compound microscope. So objective is smaller focal length, smaller aperture. Eyepiece is little big. Okay, and you are keeping the object where? You are keeping object is slightly here, so that you will get the we will get the image somewhere here, the first image. Okay, the image of the objective. Then eyepiece will form what? This eyepiece will form a bigger image, right? A bigger image. Somewhere here you can imagine it's a bigger image. So this is the image of, check it out the ray diagrams. This is the image of objective. This is the image of eyepiece. Final image. How the final image here? Final image is inverted with respect to the actual object. So reason is wrong. We don't agree the reason. In compound microscope, final image is inverted with respect to object. That's the reason why magnification is negative. So assertion is true, reason is false is the answer. At last, a small capsule to you. Keep in your mind this. Magnification negative when image is real and inverted. Image is real and inverted. If the image is inverted, then magnification will be negative. If it is not, then magnification is positive. Or else magnification is positive. Image is, magnification positive, in which case then erect and virtual. Erect and virtual. Okay, that's the last point. Keep in your mind that fact. All right. Hopefully you all solved these questions very beautifully. All right. If anything you had to talk to me, please let me know in the comment box. Obviously, your comment and subscription is needed for this channel to survive. Okay. So thank you so much, Rafi sir, physics teacher, Excel Education Center, signing off.